Okay, let's get started with chapter 5. In chapter 5, we're going to look at using the trig identities we already know, verifying some new trig identities, and then sometimes just simplifying trig identities. Then we'll move on to solving equations with trig functions. Okay, so our essential question for this section 5.1, is how can I use, recognize, and simplify trig identities? Okay, so for this whole section, we're going to be doing quite a bit with trig identities. So to simplify, to rewrite, to prove trig identities, equations, expressions, we have to make sure that we recognize all the trig identities that we've already seen in chapter 4. So this huge list of trig identities you might want to have just kind of next to you every time you're working with chapter 5, especially in the first 2 or 3 sections. It's just nice to be able to go back at one nice concise page and see, okay, do I have anything here that I can use to help me out and help me simplify or verify expressions. So we have the reciprocal identities we talked about before, right? Sine is the reciprocal of cosecant. Cosine is the reciprocal of secant and vice versa, right? And tan is the reciprocal of cotan. We also talked about the Pythagorean identities, right? So we'll come back to these a little bit later. Cofunction identities, before they were just kind of nice to know. Now if I have an expression or an identity that I'm trying to verify and it has something like this, pi over 2 minus 90, pi over 2 minus theta or 90 minus theta, I have to use the cofunction identities. Same with even and odd functions. And then this is just our knowledge of kind of SOHCAHTOA and the reciprocal. So I just add that down there just in case. So let's go back to these Pythagorean identities. We have sine squared theta plus cos squared theta equals 1. We can see a variety of Pythagorean identities, or forms, I should say, of the Pythagorean identities. May be that I have a Pythagorean identity, but it's not necessarily in this exact form. Things may be moved around, added or subtracted to both sides. So we have to be able to recognize anytime I see a square, right? Sine squared, cos squared, tan squared, cotan squared. Anytime I see a trig function that's squared, I need to go to these Pythagorean identities and say, hey, can I use one of these to help me out? So let's just take sine squared plus cos squared equals 1 as an example. So the identity that we have there is sine squared theta. It could say x, could say alpha, could say beta. This angle here can be represented by any variable. Right? Remember, theta, alpha, beta, those are all Greek letters, so they're still considered variables. Sine squared plus cos squared equals 1. That's what we're used to seeing. But sometimes you may see this manipulated a little bit. What if I subtract sine from both sides? Right? So if I subtract sine from the left and subtract it from the right, I'll end up with a new expression that looks like cos squared by itself, because I've subtracted the sine away, and then 1 minus sine squared. Right, so I started with this original. We're used to seeing this, but if I was working with a problem that just had cosine squared, I might be able to use the fact that cosine squared equals 1 minus sine squared to help me out. And vice versa. Maybe I saw 1 minus sine squared. I know that's equivalent to cos squared, so I might be able to use that fact. Okay, so this is a second expression. I chose to subtract sine squared from both sides just to give you a new form of this Pythagorean identity, but you also could get a new form by subtracting cosine from both sides. So we'd end up with sine squared, still on the left side, and then equals 1 minus cos squared. Okay, so this is like our original Pythagorean identity, but these are variations of the exact same identity. So we just have to be comfortable with using the variations and recognizing, again, like I said, if you see a squared, any trig function squared, automatically look at the Pythagorean identities to see if they can help you out. All right, so let's do some examples. Okay, so this example says use the given values to evaluate the remaining trig functions. We're given that tan x equals square root of 3 over 3 and cosine x equals negative square root of 3 over 2. So automatically I see a root 3 over 2. I know that this is probably on the unit circle. I can use the unit circle to help me out. So what are we asked to do? We're asked to use these given values to evaluate the remaining trig functions. So we know the basic trig functions, sine, cosine, and tangent. And then we also know that if I know sine, I can find its reciprocal, which is cosecant. Same thing with cosine. If I know cosine, I can find secant, its reciprocal. And then with tangent, I can find cotangent. So in this case, I know tangent, which means I also can figure out what cotangent is because cotangent is just the reciprocal. So I have tangent of x. Cotangent of x is just going to be the reciprocal. That's all I'm going to do is flip the fraction. Numerator and denominator switch places. Right, so I had tan, and now I also have cotan. Same thing with cosine. I know cosine, which means I can find secant. So secant, again, is the reciprocal of cosine. So it's still negative. It's just the numerator and denominator are switching positions. I'm going to put 2 over square root of 3. Now, you can rationalize these denominators, but it's not required. So I'm going to just move on. But if you wish, you could multiply numerator and denominator by square root of 3 and get a nice rationalized denominator. All right, the only one we don't have is sine, which would lead me to cosecant. So to figure out sine, I can use the fact that I know this is on the unit circle. Let me just figure out where it is on the unit circle. So if I go to my unit circle, and ideally you shouldn't have to draw out the unit circle each time. You guys have a unit circle available, so you can use that to find your values. So I know in quadrant 1, everything's positive. Cosine's positive, sine's positive. But if I look at 30 degrees, that's exactly where cosine is root 3 over 2. So I'm going to use that reference angle to say, okay, well, let me figure out where cosine is negative, and then I'll use the reference angle of 30 degrees. I'm going to put here 30 degrees. This isn't good enough, right? Because I want cosine to be negative, but at least it gives me the value that I want. It just doesn't give me the right sign. So I use this reference angle and say, well, cosine is my x value. X is negative here in quadrant 2 and 3. So let me use that reference angle 30 degrees. And that would be above the 180 degrees would be 150. All right, so at 150 degrees, I have cosine is negative square root of 3 over 2. And I'll put sine there also. There's another place, right, because we said quadrant 2 and 3. So I'm going to come here and use that same reference angle, 30 degrees below 180 degrees would be 210 degrees. And again, that point here is negative root 3 over 2. My x is negative, and in this case, my y is negative. All right, so my job is to find sine. Sine is the y value of the coordinate, but I need to figure out, well, which point am I talking about? Am I talking about 150 degrees or 210 degrees? Okay. I know cosine's negative, but I also know that tangent's supposed to be positive. Right? So if I look here, tangent is sine divided by cosine, or y divided by x. So if I take a positive and divide it by a negative, I'm going to end up with a negative tan. I don't want that. If I take a negative and divide it by a negative, I'll end up with a positive tan. This is the point I'm looking for. Right? So I know that cosine is negative root 3 over 2. Now I know that sine is negative 1/2. So sine of x is negative 1/2. I actually know what x is. It's 210 degrees, but we weren't asked for that, so we're just looking at the trig functions. And because sine and cosecant are reciprocals, I also know that cosecant of x is negative 2 over 1, or you can say negative 2. So I was given tangent and cosine. Now I know cotangent, I know secant, I know sine, and I know cosecant. Okay, so I found all the 4 remaining trig functions. Let's try another example. Oops. So in this case, we're given secant x equals 4. Okay, and we're also told that that sine is greater than 0, so sine is positive. It doesn't give me a value for sine, but at least I know it's positive, so it gives me a little location I can look for. So again, we're looking for sine, which will tell me cosecant. Looking for cosine, which will tell me secant, Or vice versa. If I know secant, which I do, I can find cosine. And then last one, tangent, tells me what cotangent is. Okay, so let's use the fact that we know secant to find cosine. So secant is 4, then cosine is the reciprocal of that, which is 1 over 4. Okay. All right. So I know sine is positive, but I don't really have a value for it, and I don't have much information about tangent. But what I do know is that cosine is 1 over 4. This is not on the unit circle, so I'm not going to try to use the unit circle and figure out where that is, but I can use SOHCAHTOA. Remember, SOHCAHTOA is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So I can use the fact that I know cosine is 1 over 4, which is the ratio of the adjacent side over the hypotenuse. So let's draw a little right triangle and use that information. Let's call this angle X. My adjacent side to the angle is 1, and my hypotenuse is 4. I can use Pythagorean theorem to figure out this side, and that'll help me find sine, tangent, and their reciprocals. Right? So you can plug in a squared plus b squared equals c squared and solve for b, or we can just say my hypotenuse squared minus the leg. All right, so 16 minus 1 is going to be 15, square root of that. Go ahead and complete the Pythagorean theorem and plug in if you need to see where this square root of 15 came from. So now this is enough information for sine of x. Because sine is opposite over hypotenuse, I know it's square root of 15 over 4, which leads me to cosecant, which is going to be its reciprocal, 4 over square root of 15. And then tangent, using SOHCAHTOA, opposite over adjacent, so I'm going to put the opposite side over the adjacent side, root 15 over 1, which again leads me to cotangent, which is just the reciprocal, so 1 over root 15. So in this case, I was only given one value for the trig function, and I found the remaining 5 values. Okay.